Welcome. Today we're talking about something called the geometric mean. Before we get too deep into that specific definition though, let's review our right triangle similarity. Recall that when an altitude is drawn to the hypotenuse of a right triangle, two more right triangles are made, and all three of them are similar. So we have our original triangle ABC is similar to our medium-sized triangle CBD, which is similar to our small triangle ACD. There's an interesting result when you compare the legs of the two smaller triangles using a proportion. So watch what happens. We're going to make a ratio using the short legs of each. So AD compared to CD. Now let's compare the long legs, not using the hypotenuse this time at all. Short legs versus long legs. CD now is the long leg of the small triangle, even though it was the short leg of the medium triangle. So now we have CD compared to BD being the long leg ratio. But CD is there twice. Since the long side of the smallest triangle is the short side of the medium triangle, this copy in the proportion, that repeat, will always happen. If you consider the scale factor idea between these two ratios, this relationship pops up, that times R. Something, R is your scale ratio, something you would multiply by AD to get to CD. But also it's the same thing you take times CD to get to BD. Since it is the same number factor that gets you from AD to CD and then to BD, that CD number in the middle is called the geometric mean. Basically, the idea is that you multiply the same number twice. The number where you kind of stop off in the middle, that's your geometric mean. Now, the arithmetic mean is what you might be more accustomed to, and that mean between two numbers is if you add the same number twice. The arithmetic mean is the number, that kind of stepping stone number in the middle. But we're talking about geometric means, so we are multiplying. And we're going to try to use this idea. We're going to find the geometric mean of 2 and 8. We're going to walk through two methods of doing this. The first method is a guess and check method, which can be helpful, especially if your scale factor is a whole number. But keep in mind there is going to be a method 2 where we can use a little bit of algebra to solve this. So we have 2, 8, and the geometric mean somewhere in the middle. Now we're trying to find an R value, a scale ratio that takes us from 2 to M, but then also the same R will take us from M to 8. So again, here are our little equations that we set up on the last slide. And basically on this guess and check method, we're just going to test out different values for R. Now my first thought when I think about 2 and 8 and multiplication, I think of a 4. So let's just try that out. What if R were equal to 4? What would happen? Well, 2 times 4 is 8. But then remember that M value in the middle has to be the same. So then 8 times 4 is not equal to 8. So R is not equal to 4. 8 times 4 was 32, which is way too big for what we need. So let's try a smaller number, maybe 3. So let's reset here, and then we'll fill in our R values for 3. 2 times 3 is 6. Then 6 times 3, nope, 6 times 3 is 18. We're still too big. So let's try 2. We'll reset our formulas, and what if we put in 2 for R? 2 times 2 is 4, and then 4 times 2 is 8. We found it. R equals 2. But be careful, that is not your answer. Remember, we are looking for M, the geometric mean. We're not looking for the scale factor. The geometric mean was that stepping stone number in the middle. So the answer we're looking for is 4. Now here's method 2. There was a proportion that we set up to kind of realize that there was this copy relationship. So that copied number is the geometric mean. So what we're going to do this time, using the 2 and the 8, is try to use algebra to solve for M. Now the first thing I'm going to do, I don't like to keep these fractions here, so one by one I'm going to get rid of them. I'm going to multiply both sides by m over 1. So on the left side, my m's will cancel. On the right side, we'll end up m times m, which is m squared. And we haven't done anything with the 8 or the 2 yet. But now I still don't like the fraction with the 8. So let's multiply both sides by 8 over 1. This time on the left side, we'll keep the 8 times 2, but on the right side, the 8's will cancel each other out. So as we move down to simplify this, we end up with 8 times 2, which is 16 over 1, and m squared over 1. But really, if they're over 1, we don't need the fractions anymore. So we have 16 equals m squared. And remember, if you have something squared and you want to get rid of that squared, the square root is your inverse operation. So then we'll do the square root of 16, which gets us to 4, and the square root of m squared gets us to plain old m. But plain old m is what we were looking for. So there you go, 4 is our answer. We're going to try using this idea on a right triangle. Remember, this was where we started the video with imagining this ratio, this relationship. So keep in mind the two small right triangles are similar, so we can use a proportion. Here's the proportion we had set up before. But let's go ahead and get our actual numbers in. So 4 is our little side. X is that altitude that both triangles share, and then 16 is from the bigger triangle. Now, you can use either method that we talked about to solve for x. You can use that guess and check. You can use the proportion method. We're kind of set up on the screen right now for either one. So take a moment, pause the video, and see what you can do. Now, on a guess and check, hopefully you found out that timesing by 2 could get you your stepping stones that you need, which means that the geometric mean is 8. That altitude length is 8. If you used the proportions, you would have ended up with 4 times 16 equaling x squared, 4 times 16 being 64, and then the square root of each will give us 8 equals x. So either way that you do it, you get the same answer. But this gives us a way to relate the two different pieces of the hypotenuse of a right triangle when it's split by an altitude to the altitude itself. The altitude is the geometric mean of the two pieces of the hypotenuse. So thank you for joining for this talk about geometric mean, and I will see you soon.